Chapter 7, Lesson 6, Solve Systems of Linear Inequalities. So now we're going to be talking about how to solve these systems of two sets of inequalities and figure out where both of them are actually true. I do want to recommend that you review the material from the other videos. Just briefly look and see, just to refresh your memory on the other ways of solving linear equations. And just as a reminder on how to work with those, because obviously it's been a little while because of winter break. So now we're going to talk about this. A system of linear equalities in two variables, or simply a system of inequalities, consists of two or more linear inequalities in the same variables. A solution of a system of linear inequalities is an ordered pair that is a solution of each inequality in the system. So very quickly, this here is just a system of inequalities. Anything that's over here in this section here is true about both of those, so that any point in that section would be an actual solution. So let's go back here. The graph of the system of linear equalities is the graph of all solutions of the system, and that's what I just pointed out. So basically what you do is, first of all, you graph each inequality. So graph them as if they're lines, and then that's the very first step. And remember the thing about the dashed lines, if it's y is greater than 3x plus 5, and then solid lines if it's y is greater than or equal to 3x plus 5. So then you find the intersection, the half planes, and then you graph the graph of the system is that intersection. Basically, you're going to graph two things where the solutions are and then see where they cross over. So let's look and see here. So what's happening here is, let's see here. What's happening here is it says two inequalities. Y is less than 1/2 x plus 2. So y is less than 1/2 x plus 2. That is going to be this inequality right here. Then, and it's anything that's underneath there, because it's less than. So that's the solution to that part. Now this second part here, the second inequality, is this one here. Y is greater than or equal to negative 2x plus 5. And so that's going to be this, this line right there. And then we see where the solutions are for each of those, and it's everything that's on this side. And if you notice, there's one section, and I'll actually do it in green here, this part here, that both is blue and red, because it is a solution for both of those inequalities. And that's why it ends up being this is the graph of the inequality, because it's basically going ahead and looking at these two different where they overlap. And it says here the graph of the system is the intersection of the two half planes, and it's basically, if you imagine each, that basically the red half plane and the blue half plane, where the intersection is, that's where I put the green half plane, and so that's the solution. So let's look at this and see how it works. So remember, when we graph inequalities, we're just graphing the lines to start with. So this is just going to be y is equal to 3x. That's the first part here. So I'm just going to put down y is 0, 0 is a point, where 0, 0 is going to be a point. Do 0 first, because there's no y-intercept when x is equal to 0. Y is going to be equal to 0 too, because you remember the y equals mx plus b thing. And that's the slope-intercept form. So now when x is equal to 1, what's y going to be equal to? Y is going to be equal to 3. When x is equal to 2, what's y going to be equal to? It's going to be equal to 6. So let's just do when x is 1, y is 1, 2, 3. When x is equal to 2, it's 1, 2, 3, 4, 5, 6. So right there. So that is going to be our first part there. And remember, it needs to be a dashed line because it's y is less than or equal to 3. So let's do my best here. You get the idea, even if it's not perfect in terms of that. And so where's the solution? We can't use 0, 0 as a solution because basically 0, 0 won't work with this. 0, 0 is one of the places that goes through. So let's use a point on the line that doesn't actually work to test and see which part we're going to shade in. So we're going to go ahead and do that with, let's see here, for x, when x is equal to 1 and y is equal to, let's say, 0. When 1, 0, because that's the first one for that point right there, is that a solution is 0 less than 3 times 1? Yes, it is. So we know that everything on this side is a solution. I nearly forgot to do my little, get rid of the part of it there. So everything on that side is a solution. That's the half plane that's colored in. So now we need to deal with this part here. This one I'm going to do in red. So y is equal to negative 2x plus 1. So let's just solve that, and when x is equal to 0, what's y going to be equal to? Y is going to be equal to 1, so it's going to be right about there. Let's see, right about there. When x is, so that's when x is equal to 0, y is going to be equal to 1. That's the y-intercept. When x is equal to 1, what's y going to be equal to? Negative 2 times 1 is negative 2. Or it's just negative 2 times 1 plus 1. We just have to figure out what that is when x is equal to 1. And that's going to give us negative 2 plus 1. So it's just going to be equal to negative 1. So the point is going to be 1, negative 1. Which makes sense because it's over 1 and down 2. Over 1, down. Over 1 and down 1. So it's going to be right there. And then we can do one more point as well. So if we have x is equal to 2, what's y going to be equal to? Negative 2 times 2 plus 1. Negative 2 times 2 is going to be negative 4 plus 1. It's going to be negative 3. So negative 2, or so 2 over, 1, 2 over, 1, 2, 3 down. So it's going to be right about there. So it's going to be, again, a dash line. This time I'll remember it's a dash line to start with. I know this is not perfect, but now I still have to do the same thing. I have to see where it actually matches up. So I'm going to actually erase this part down here because we already did this part for there. So now I'm just going to choose, again, that I can choose that same point. I can choose 1, 0 again. Actually, you know what? I'm going to choose something that's a lot bigger because I think that's a little bit easier to see. Let's choose 5, 0, and see if that's a solution to this inequality, to the red inequality right there. So is 0, I'm just plugging in the values here, is 0 greater than or equal to, oh actually it was greater than or equal to, so it's not a dashed line. My mistake. Is that, so negative 2 times 5 plus 1. Is that true? Is 0 greater than or equal to negative 10 plus 1? Well, is 0 greater than or equal to negative 9? Yes, it is. So everything on that side, everything on this side, so 5, 0 is a solution. So everything on this side here is going to be a solution. And if you notice, there are certain parts that are not solutions and there are certain parts that are solutions. So like right here, that's a solution for the blue line, but it's not a solution for the red line. Up here, that's a solution for the red line, but not a solution for the blue line. Up here, that's a solution for neither, but this is the part we're actually really concerned about because this is the part that is the solution for the two inequalities together, because that's where the red and the blue overlap. That's the reason why it's helpful to have two markers and to do it that way. So same sort of thing, you do the exact same thing and then you just see where they overlap. Promise that most of my videos would be about 10 minutes or under, so I'm going to stop there. We will definitely go over this more tomorrow, or excuse me, on Tuesday in class.